So everybody hates Roman numeral problems, but this one's not so bad. We gotta just check everything and see what's what. The first thing to do is focus on the pattern and see if you can see what's going on with the pattern. Of course, this one's not too hard to figure out, especially because they tell you. Each term after the first term is determined by multiplying the previous term by 4. Right? So we can actually rewrite this a few different ways. We can also say that 1 is 4 to the 0, 4 is 4 to the 1, 16 is 4 squared, 64 is 4 cubed, right, etc. So that's actually, this is going to be the key to us seeing what's going on with Roman numeral 1. Roman numeral 1 is not true because the nth term is not equal to 4 to the n. The first term is equal to 4 to the 0. The second term is equal to 4 to the 1. So the nth term is not equal to 4 to the n. The nth term, in fact, is equal to 4 to the n minus 1, right? That's what it means when you see the first term, when n equals 1, the first term is 4 to the 0. That's 4 to the 1 minus 1. The second term is 4 to the 1. That's 4 to the 2 minus 1. So the nth term is not equal to 4 to the n. It's equal to 4 to the n minus 1. That unlocks the second Roman numeral, because if we know it's equal to 4 to the n minus 1, well, then we can rewrite 4, right? 4 is also 2 squared, right? So we can do a little substitution here. This is 2 squared to the n minus 1 for the nth term. And of course, when you have exponents raised to other exponents, you can do a little rearranging. So you multiply the exponents when you raise them to other exponents. So we're going to say that's 2 to the 2 times n minus 1. And looky looky, that's exactly what this is, right? So Roman numeral 2 is true. And then Roman numeral 3, the units digit of the 53rd term is 6. Well, look at what's happening here. 1, forget about 1, this is the anomaly. Then you have 4, 6, 4, and what happens when you multiply something that ends in 4 by 4? The next term is going to be, is going to end in 6, and I believe it's 256, right? And you can keep going, and you're going to see that, you know, the second term, the fourth term, the sixth term, those are all going to end in 4. And the third term, the fifth term, the seventh term, those are all going to end in 6. The pattern here is that the units digit just goes 4, 6, 4, 6, 4, 6, right, etc. And so the even terms will have a 4 as a units digit, and the odd terms will have a 6 as a units digit. 53rd term is an odd term, so yes, it will have a 6 as a units digit. The answer we want here is 2 and 3 only.